Optical isomerism is divided into two main types. First is the enantiomers and second is the diastereomers. First of all, we will discuss about the enantiomers. What are enantiomers? Enantiomers are such compounds that having same molecular formula, same structural formula, same order of connectivity of atoms and the same bond sequence, but they are differ with respect to the three-dimensional orientation. They are differ with respect to the three-dimensional orientation of atoms or bonds in space. And they show different behavior towards plane polarized light, towards optical rotation. And they also show different behavior towards other chiral compounds. Enantiomers show different three-dimensional orientation of atom and bonds in space, and they show different behavior towards the plane polarized light, and they also show different behavior towards other chiral compounds. They have identical physical and chemical properties like melting point, boiling point, density, refractive indices, and solubilities. Enantiomers have identical physical and chemical properties. Enantiomers have one or more than one stereocenter. Enantiomers have identical NMR spectra, UV spectra, IR spectra when they are measured in achiral solvent. Enantiomers have identical NMR spectra, UV spectra, IR spectra when they are measured in the achiral solvents. Enantiomers, they are also known as dual pairs, show identical rate of reactions with achiral reagents. When they are treated with achiral reagents, but they show different behavior. And they show different rate of reaction when they are treated with chiral reagents, with other chiral compounds. Enantiomers or dual pairs show different rate of reaction when they are treated with other chiral reagents. So these are all the characteristics that enantiomers have. And the most important characteristic is that enantiomers are non-superimposable mirror images of each other. So these are all the characteristics that are possessed by the enantiomers. They show different or three-dimensional orientation of atoms in space, show different behavior towards plane polarized, show different optical rotation, and they show different behavior towards other chiral compounds, have identical physical and chemical properties in the achiral environment. They have one or more than one stereocenter, so they possess optically activity. Enantiomers have identical NMR spectra, UV spectra, IR spectra when they are measured in achiral solvents. Enantiomers or DL pairs show same rate of reaction or identical rate of reaction when they are treated with achiral reagents, but they show different behavior or different rate of reaction when they are treated with other chiral reagents. So these are all the characteristics of the enantiomers. Enantiomers have identical physical and chemical properties, so they cannot be separated by physical techniques like fractional distillation or crystallization. This is lactic acid, and if I place a mirror here and draw another enantiomer, draw another isomer, then we can see that they are non-superimposable mirror images of each other. So these are lactic acids. One, they are enantiomers of each other because they are non-superimposable, non-mirror images of each other. They show different optical activity. If one rotates the plane polarized in the clockwise direction, the rotate the plane polarized light in the anti-clockwise direction. So for positive lactic acid, the value of specific rotation is plus 3.82, and for negative lactic acid it is minus 3.8.